How do you find the x and y intercepts? Whenever I want to find the y-intercept, I say x equals 0, x-intercept, y equals 0. If I have a graph and I want to find my x-intercept, well, let's do ordered pairs. This is 1, 0. This is 3, 0. This is 5, 0. And what do they all have in common? The y is equal to 0. Because the only way to be on the x-axis is if y equals 0. And the same is true in reverse for the y-intercept. No matter what point I pick, I can't go off of the axis, so x has to stay 0. And I would have 0, 1, 0, 3, 0, 2. Always the x is going to be equal to 0 when I want to find where the graph hits the y-axis. Find the intercepts. Honestly, the x-intercept is the harder of the two. Let's start with the y-intercept. The y-intercept, x equals 0. When x equals 0, well, this is 0, this is 0, and this is 0, because 0 times anything is 0. All I really have to look at is my constant term, which is 4. The y-intercept is equal to 4. Or I can say 0, 4. The harder one is the x-intercept because 0 equals x cubed minus x squared minus 4x plus 4. And once I say that, well, I have to factor. I have 4 terms. The only way that we've learned to factor 4 terms is factor by grouping. So that's what we'll do. I'll group the first 2 together. I always put a plus between them, and then I take that negative sign and put it inside the parentheses. Then I find my greatest common factor for each group. In this group, my greatest common factor is x squared. And I factor out the x squared, and I get x minus 1 plus. And now in the second group, my greatest common factor is 4. But I never want my leading term to be a negative. What I'm going to do is factor out a negative 4. And when I factor out a negative 4, I get x minus 1. And now we can see these are the same. We factor that out of both terms. So I get x minus 1 times x squared plus minus becomes minus 4. I'm not really done yet because x squared minus 4 is the difference of squares, and it's still factorable. My final factoring is x plus 2 times x minus 2. Now, all of these equal 0. Once I have it in this form, I know that if I multiply 3 different terms together, that equals 0, that either A has to be 0, B has to be 0, or C has to be 0. There's no other way for me to multiply 3 numbers together and get 0 unless one of those numbers is a 0. And I'm going to use that fact here when I say either x minus 1 has to equal 0 or x plus 2 has to equal 0 or x minus 2 has to equal 0. If any one of those 3 factors equals 0, then the whole thing is going to equal 0. If x minus 1 equals 0, if I add 1 to both sides, here I get x equals 1. Here I get x equals negative 2. And here I get x equals positive 2. Those are my 3 x-intercepts. I have 3. The most intercepts I can have is the same as the highest degree. I could have less, but I can't have more than 3. I could have 2, I could have 1. I have at most 3. That's how we find our x-intercepts. Each one of these, if I were to graph it, and I'm not going to graph it yet, but if I were to graph it, I know that I have an x-intercept at 1, 2, and negative 2. I know for sure those 3 points are on the graph. And then for my y-intercept, it's at 4, 1, 2, 3, 4. Now we want to talk about what the zeros mean. We found our zeros, and those are called factors. If x minus c is a factor of the polynomial, then x equals c is 0. That's what we found here. X minus 1 was a factor, and then if we add 1 to both sides, x is equal to 1. That's all they're saying, that the c is a 0. If a factor x minus c occurs n times in a polynomial, n is an integer greater than 0, then the 0 x equals 0 is said to have a multiplicity of n. For example, I had x minus 2 squared times x minus 1 times x plus 3 to the 5th power. My zeros are 2, 1, and negative 3. The multiplicity on the 0 that's 2 is 2. That multiplicity is 2 because this would be the same as saying x minus 2 times x minus 2. So I'd have 2 zeros there. X minus 1 doesn't have an exponent, so we can say it's 1. It has a multiplicity of 1. And then the 1 at negative 3 has a multiplicity of 5. It's the same as saying x plus 3 times x plus 3 times x plus 3 times x plus 3 times x plus 3 5 times. That's called the multiplicity. How many times we have that 0. Determine the real zeros of a polynomial function and their multiplicities. In the polynomial, f of x equals x minus 1 squared, x equals 1 is my 0. X minus 1 equals 0, so x equals 1. And it has a multiplicity of 2 from the exponent. Here again, I have the same 0 at x equals 1, but now we have a multiplicity of 3. If I just circle right around my 0, which is at 1, notice it takes the shape of the parabola. It says graph will touch the x-axis at a real 0 with even multiplicity. If you have something that's even, the 0 at that position will look like a parabola. It'll bounce off of the axis. If it's odd, it can cross. Notice here, if I made this graph really big and I made that circle really small, it would look like a straight line. Anytime you have odd multiplicity, it crosses. The graph will touch the x-axis with even multiplicity and cross the x-axis with odd multiplicity. And this is telling us why. The shape of the graph of a polynomial function near a 0 of multiplicity k. If this is where my graph is hitting the x-axis, I can tell if I have x minus c to some power, that power has to be even. And if it's odd, then you can see that it actually looks like a line. So I can tell that this has an odd multiplicity, so x minus c to some power would be an odd power. And I know that because it's crossing.